finally start talking about object capabilities. That is, in a pure object-oriented setting, in order to do an action, you need to call a method over an object receiver. This means that if you can somehow control which objects can do a certain action, and you can make sure that only certain parts of a program have access to objects that can do certain important actions, then all the other parts of the program will be unable to do that action. In short, no object, no action. We can make a good example of this with access to the file system. In most languages, for example in Java, in any point, anywhere, you can just write new file and start writing on a file. Instead, in 42, you need access to a file system object that will have a mute method that will let you access to files. And you will not be able to create this file system object anywhere in the code. You will only be able to create it in certain privileged places, basically in the mains. So let's see this in concrete. We can load a file system library by doing fs equal load colon curly bracket reuse l42.is/file system. To create this special privileged file system object, we will use the special syntax $. If you remember, methods that start with hash in 42 represents that they are a little bit dangerous to use. Well, there is a second level to that. Methods that start with $. Are like very dangerous to use, are methods that can do absolutely everything. So here we use an $of method to create an instance of the privileged file system object. That is, in line 2 here, by writing fs.real.$of, we are saying, yes, I understand the risk, I understand this library fs, I trust that this library that was downloaded from this URL is just doing something that I expect, that is, in this case, allowing access to the file system, and I create an object capability that will have all the power that this library encodes, and in principle, this library could do absolutely everything. I, the programmer, trust that this library is just going to access the file system. Security in 42 is based on a division of roles. Any programmer that is allowed to write a main can, in principle, create any kind of code, can create code that do absolutely everything. However, programmers that just write regular methods, that is, methods that do not start with $, can only encode two kinds of computation: normal deterministic code and non-deterministic code that can interact with the system only going through an object capability that has been received in input as a mute parameter. A programmer that writes a method that starts with $, is a security architect. He is able to write a method that can do absolutely everything, but this method can only be called inside of other $, methods or inside of mutable method of capability objects, that is, objects that are created with a $. factory. Then, when finally the main programmer will put all the code together by writing the mains, he will be able to instantiate object capabilities and call $, methods in general, and in this way he will be able to create objects that have a specific set of capacities, a specific set of capabilities, a specific set of things that they can do. and they will only be able to do certain things and no more. All of the rest of the code, including, most crucially, all the code that we can import from any other library that we can just load from the internet, will only be able to do non-deterministic behavior if and in the way that is allowed by the object's capability that have been designed by the security architect, that have been created by the main programmer, and that have been propagated through them, through the execution flow. Coming back to our example of the file system, as you can see here, we have two types. We have fs and fs.real. The idea is that fs is an interface and fs.real is a standard implementation for that interface, and it's representing the real access to the hardware, to the actual concrete file system. And so we can create a concrete instance to the file system and assign it to an fs, an interface that represents a kind of file system access. Then, with our mutef, we can do non-deterministic operations like writing or reading on a file. In this simple example, we write some content 0 on the file. We then read the file and we save what we have read in the string s. And then we write on the file some content, that is, without the 0. Then, in line 8, we are going to print the content of s. And what do you think this is going to be? Well, if you think it's going to be some content 0 just because we wrote that on the file in line 3, well, I have a very bad news for you. It could very well be that between line 3 and line 4, another process had access to that file and wrote something else on it. Remember, on practically any operating system, when you read from a file, you are reading random data. You cannot really trust what you are reading. So you can say, in most realistic setting, I'm assuming that no other program is going to mess with my files, but it's never guaranteed, okay? Formally speaking, whenever you read random data. Of course, we don't want to just read and write files all in the main. So here we show how we can have a class method that just take a mutefsf, and exactly as we have shown in the main, we can make non-deterministic behavior inside the method. However, we are doing it by using the mute object capability f that we take in input from the method. Is this read-write static method actually reading and writing files? Can we be sure? If you remember, fs, it's an interface, so we cannot be sure that all the calls to read-writes are going to receive an fs.real. And this is great news. This means that our code is now testable. That is, we can just implement the interface fs with our mock implementation, and then we can call any function that is parametric on the fs interface, and we can test them without actually having to engage the real file system. Mock don't actually talk with the real file system, but has a var slog that is going to represent how this fake file system is used. Then, for all of the methods of the fs interface, we make an implementation. So, for example, for delete and make dirs, we just throw arrowx. We don't expect those methods to be called in the particular tests that we are writing this mock implementation for. The read method is implemented starting with an assertion. We expect this test to just call the read method with the parameter to be exactly equal to data.txt. Then we fake the content of the file data by returning all the content. And we log that a read happened. Our assertion is checking that the user is giving us the expected parameter. But if the user was, for example, to never call the method, well, our assertion will never be triggered. If we want to be sure that the test under code is calling our read method exactly one time and exactly with the parameter that we expect, we can make the assert to check that the parameters are as we expect in the start of the method, but we also need to log that the method has been called, so that in the end we can check that this happened. Read base 64 and write on content base 64 are also methods that we just don't expect to call, while the method write is handled exactly in the same way of the method read. That is, we check that the parameters are exactly what we expect, and we log the event that this method have been called. Finally, we make our test. And remember, every good test is divided in 3 parts. First, we create mocks and data. In this case, this is line 19. We create our mock object. Then we run our code by passing the data. Finally, we run our actual test, checking that the result of executing that code had exactly the effect we wanted. As you can see, this technique do much more than just checking that from some input we run our code and we get the expected output. We can check that all the interaction that the algorithm had with all of the objects that we provide are following exactly the pattern we want. So we can make a very, very precise test that is checking not just the input-output, but also everything that happens inside. In my opinion, the possibility of writing these kinds of tests this easily is one of the big advantages of object-oriented programming. This idea that the file system is separated in 2 concepts, the fs interface and the fs.real class, it's also fundamental for security architects because they can use the decorator pattern to create very sophisticated watchdogs for object capabilities. For example, here, only.txt, it's following the decorator pattern and it's implementing the file system library, and it has a single field mute file system inner. This field inner is going to end up hidden inside the underbelly of the object only.txt. And so, all the code that is a user of only.txt will only be able to access inner indirectly. It's only going to be able to access inner going through method calls as designed by only.txt. Here we are implementing this checkTxt method that checks that every URL ends with .txt. And then we throw an error for makeDirs. Then we directly outlaw methods makeDir, write and read base 64 by just throwing an error first thing if they're called. So every user of only.txt is not going to have any way to use those methods to actually make directories, for example. Then the other 3 methods, delete, write and read, will check first thing that the provided URL starts with .txt. If our check passes, we will then delegate the behavior on our inner field. Finally, we make 2 public factories for our only.txt class. One in line 24, that is the standard decorator factory. That is, we take a mute file system interface instance and we wrap it around inside of us. The other one is an all-powerful $$ method that is going to create a real file system by doing fs.real.hash$, and it's going to wrap it around an only.txt instance. That is, only.txt is now also an object capability that have this specific set of actions that can do exactly this very specific set of things on the file system. Finally, our main programmer will be able to use the code created by the security architect and just get an only.txt instance. By passing this instance to the possibly untrusted read-write code, we are limiting this code to only edit txt files. As you can see, with this pattern, we can make any arbitrary user-defined security property, and we can enforce it. By controlling the flow in the program of object capabilities, we can control the program behavior. The pattern shown above, it's very, very flexible. That is, we can combine and nest one inside each other many of those restrictions. We can define many different kinds of object capability decorators, and using their factory, taking another file system instance, we can just put them one inside each other. So, for example, here we have 3 layers. The first layer creates the full file system.real. The second layer wrap it around an only small files that will only allow you to interact with files smaller than 3 megabytes, for example, I don't know. And then the third layer wrap it around only.txt. In this way, any code that receives fs will only be allowed to interact with small txt files. Okay, this is all for today. See you next time!